Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem stock buy and sell, max one transaction allowed, which is an easy level problem and it is very similar to yesterday's problem that we have solved. Although we can solve this problem using yesterday's approach through dynamic programming by introducing extra parameter there. So let's read the problem description first. The problem says given an array prices of length n representing the prices of the stocks on the different days. That is, we have been given prices array of length n which represents price of stocks on different days. The task is to find the maximum profit possible by buying and selling the stock on different days when at most one transaction is allowed. It says we have to maximize the profit by buying and selling the stocks on different days where only one transaction is allowed. Here, one transaction means one buy plus one sell. If it is not possible to make a profit, then return 0. And here it is stating that what does one transaction means. It means one buying plus one selling, and if it is not possible, then we have to return 0. And here there's a quick note saying stock must be bought before being sold, which is a common sense point, right? That if you have any stock, then only you can sell it, right? So the problem description is pretty clear. Now let's dive into examples. So in example 1, the prices array given is 7, 10, 1, 3, 6, 9, 2, and the maximum profit is 8 it saved. Now let's see what explanation says. You can buy the stock on the day 2 at price 1 and sell it on day 5 at price 9. Hence the maximum profit is 8. That is, we have bought the stock here and we are selling it here. So the difference between them, which is 9 minus 1 equals to 8, is our actual maximum profit. And in example 2, the prices array is 76431 and the output is 0. The explanation says here the prices are in decreasing order. Hence, if we buy any day, then we cannot sell it at a greater price. Hence, the answer is 0. Suppose we are buying a stock at price 7, but to sell it and maximize our profit, we can't see any price greater than this. Similarly, for 6432, there is no price greater than them in the afterwards array because the array is in decreasing order, right? Therefore, the output is 0. Now, since we have understood both examples, let's consider the example 1 and get some observations from here. So, our main aim is to maximize the profit, right? Now, let's suppose we have to sell a stock at price 6. Now, what do you guys think that we have bought at the price from the past so that we can maximize the profit when we sell at 6? Yes, it's 1. If we had bought the stock at price 1 and if we are selling at price 6, then the maximum profit that we are generating is 5. So 5 is the maximum profit that we are generating when we are selling at price 6 and buying at price 1. So at the price 6 from the past, if we had bought at price 3, do we justify the maximum profit? No, because if we buy at 3 and we sell at 6, the profit that we are generating is just 3, which is lesser than the maximum profit that we already know. So at any given point from the past, we need to find at what minimum price we had bought the stock so that we can maximize the profit, right? So it is a clear observation that at any point you need to find the minimum element from the past. So for this, what is the brute force thing that you can do? You can keep your pointer here to keep the track of the price that you are selling at, and from the past find the minimum element, and whichever minimum element that you find from this segment, just subtract it from here, then you'll get your maximum profit. So this is how our brute force approach looks. First we run a loop from 0 to n minus 1 to keep the track of the pointers that we are potentially selling them, okay? And inside we run another loop from j equals to 0 to I minus 1. That is, whenever we are selling, preceding to that from the start, okay? And we keep a track of minimum price from that, what at minimum what price we are buying it at, okay? And after we come out of this loop, the maximum profit that we need to generate is maximized as at the price that we are selling at and the minimum price that we have achieved from the past, okay? And whatever maximum profit that we generate, at the last we return it. So this is the brute force approach. Now clearly the time complexity for this approach is O of n square because we are running two loops, and the space complexity remains 0 because we are not using any extra space. So this is the brute force approach, but this solution doesn't get passed. So we need to optimize the time complexity from n square to somewhere O of n log n or O of n. Okay. So for sorting, if we do the sorting or any other stuff, the structure of array gets distorted. But we should not be modifying the array, right? So we need to bring this solution from O of n square to O of n. Okay. So now let's discuss the O of n solution for it. But before that, if you had got this approach in your mind before I explained, congratulate yourself because you have cracked the brute force solution of it, right? And cracking it with brute force approach is one of the best feeling that you will have. That at least you know the solution, right? So from this brute force approach, what do you guys think we can optimize so that we can bring the solution to O of n? Here we are learning a loop from 0 till the preceding index of the selling index to find the minimum price. So we have to get rid of this for loop. Now to get rid of this for loop, we need to keep the track of minimum price. Now one of the main observation is that we are considering each element as the selling price. Okay. But this selling stock could be a buying stock for any other stock, right? I know it's confusing what I just said now. Suppose you need to sell the stock at price 1. For this, we will find the minimum price from the past and try to maximize the profit. Okay. So you are basically selling the stock here. Now, when you're selling at price 6, the one that you considered as selling till this point will be as a buying stock, right? That is, you're selling at 6 when you bought at 1. Are you getting what I'm trying to say? Till this moment, it was a selling stock. But at this moment, when you're selling at 6, it is acting as you have bought it from the past, right? So what I mean to say is, for every stock that you are considered as selling stock, will act as a buying stock if in future you get any stock price greater than that. Okay, so this is the main idea, that is whenever you're selling a stock, right, keep the track of it so that it could be a buying stock for some higher price selling stock, right? Now since the observation is semi clear, let's write on the example and make the observation fully clear. So here we are keeping track of two variables. One is minimum price and the maximum profit that is generated. And how maximum profit is generated? The difference between the price that you're selling at and the minimum price you bought it, right? It's basic mathematics. Now we'll start from index 0. At index 0, the price is 7, which is lesser than the minimum price because we considered minimum price as maximum as possible to minimize it. So the minimum price will become 7. And what will be the maximum profit? The maximum profit will be the difference between the selling price and the minimum price. So 7 minus 7 will become 0. So the maximum profit remains as 0. Now we'll go to index 1. At index 1, we'll check whether this price is less than the minimum price. No. So we'll not minimize the price more. And what will be the maximum profit? It is 10 minus 7, which gives us 3, right? And 3 is greater than maximum profit. So the maximum profit becomes 3. Okay. Now we'll go to index 2. At index 2, we'll check whether this price is less than the minimum price. Yes. So we'll minimize it to 1. And what will be the maximum profit? It will be a difference between 1 and 1, which gives us 0. But maximum profit is already 3, so we'll not maximize it. Now we'll go to index 3. At index 3, the price is 3, which is not less than minimum price, so we'll not minimize the price. But the maximum profit will be 3 minus 1, which gives us 2. But since 2 is less than 3, so the maximum profit still remains 3. Then we'll go to index number 4. Here the price is 6, which is not less than minimum price, so the minimum price remains 1. But what will be the maximum profit? Maximum profit will be 6 minus 1, which gives us 5. And we'll check whether the 5 is greater than 3. Yes. So we'll maximize the profit from 3 to 5. Simple. Now moving to next index, at index 5, the price is 9. First we'll try to minimize it, but 1 is already less than 9, so minimum price remains the same. And the maximum profit will be 9 minus 1, which gives us 8. And we'll check whether 8 is greater than 5. Yes, so we'll maximize the profit from 5 to 8. Okay. And finally, at index number 6, the price is 2. First we'll check, can we minimize the price? No, because it's already 1. And the difference between 2 and 1 gives us 1, which is less than the maximum profit. So here our execution is complete and 8 is the maximum profit that we have generated. And if you see in the prices array, the difference of 9 and 1 gave us the maximum profit of 8. So in one iteration itself, by keeping the track of minimum price, we have found our maximum profit. Okay. Now, now since we have also understood the example clearly, let's jump into the code. So here's the code in C++, although the logic remains same. So we have been given a function maximum profit where we have prices array and we need to return the maximum profit. Okay. Okay. So firstly, I have taken prices size, and here I have taken two variables. One is min price, which I have kept it maximum so that we can minimize it at minimum as possible. And second is maximum profit, which is 0. Okay. So I am looping from 0 to n minus 1. And before processing the max profit, I'm always keeping the track of minimum price. And after finding the minimum price, I'm trying to maximize the profit by taking the previous maximum profit and the new potential maximum profit if found any, that is prices of I minus minimum price. Okay, and after this loop gets executed, whatever maximum profit we have, we are returning it. Okay, so the code is pretty small, but the observations, the content that we have consumed is way greater than this. Okay, now what will be the time complexity for this approach? Since we can see we are just running one for loop, so the time complexity remains O of n, where n is the size of prices array. And that's what we wanted to minimize, right? And what will be the space complexity? Since apart from variables, we are not taking any extra space. So the space complexity is O of 1, that is the constant space. Okay. So this was the video, guys. I hope you like this video. If you have liked this video, please like, share and subscribe. And if you have any doubt at any point, comment it down. I'll try to respond it as quickly as possible. And if you have any feedbacks for my teaching, please comment it down too so that I can improve in that. So let's meet in tomorrow's video solving any other coding problem. Till then, stay safe, stay happy, and peace.